Alright, boys. Alright, boys. Am I live? Testing, 1, 2. Testing, 1, 2. Alright, boys. I have a huge announcement to make. I've come up with my most idiotic idea yet. Everyone on Earth will facepalm in disgust. That's when you know the idea is awesome. Okay. I'm so excited about the idea. I don't even want to announce it. I'm so excited. I do want to announce it, but I want to procrastinate announcing it because it's that good. I don't even want to say it. It's too good to even say, to even speak it. It's like not even allowed. Okay, guys. This, for some reason, whatever makes me weird or whatever is like flipping out at this. Flipping out completely. So you guys know I have this like theory or something pulling in me that I want to try to go as low level as I can as a software developer. The higher level you make it, everything's so abstract. There's abstraction layer upon abstraction layer. Eventually, you don't know what the heck's going on. It's all magic. And you're just stumbling about in darkness, trying to read documentation of other people's work, and you really have no clue what's going on. And you cross your fingers and hope things work that other people made. And then their code's bugging out. Your code has no bugs, but things are glitching and whatever, and it's not your fault. And you have very little control of the final outcome. And then to actually like be able to do that really well, you have to like understand the underlying stuff anyways in some roundabout way. And you have to be like super, super knowledgeable on low level programming and somehow be able to track deep into what's even being done in the background. I know like George Hotz recommends everyone to take assembly language as their first language so they can understand what's going on behind the scenes when they're using a higher level language. And then I think he said like after that learn like C, and then after that you learn Python or something like that. So you need to like know the different layers underneath your higher level stuff. Well, I don't want to do that. I just want to use C++. I want to use just one programming language when it comes to desktop software. And so how do I understand underlying stuff a little more at least? By taking on coding challenges where I don't use as high level of libraries. This idea of creating my own SFTP client where I'm actually coding the SSH packet reading and stuff, that's pretty deep. And I'm learning so much and it's so interesting. And I could have done all this with like 4 lines of code using like curl, which is like a super high level library. But then I'd be spending countless hours just reading curl documentation. So now I become a curl expert, and curl might not even last. So I became an expert on some super high level thing that may someday be abandoned for some other super high level thing, and then I have to just... You become an expert at using frameworks, which come and go, and just using high level APIs, which come and go, and can be deprecated. And then you can't use the latest version. You'd have to learn how to use the latest version. It's just like... No, I don't like doing it. Now, I get it that people that need to move quickly, whatever, have to do it or whatever, but in the long term, I think you'd be learning way more and be way more powerful and dangerous at the keyboard if you coded whatever that library is that you're trying to learn, if you just made the underlying code yourself. And sometimes that will involve using ChatGPT to help you, but also maybe following along with an open source library that does it. So in my case, in order to create my own SFTP client, I downloaded libssh, which has an SFTP client implementation as part of that library. And I just copied the whole library into one big file, and I studied it. I'm following along step by step, working through it, reverse engineering it, and recoding it in my own way, so it's sufficiently recoded. I'm not just copy pasting, and I'm just making my own implementation from scratch in C++. And that's making me very, very understanding of what's going on. It's super satisfying to me not to have to now rely on some library. All the code is just going to be hard coded directly into my program. So I don't have to like link to libraries and hope the library's not glitchy and like not really know what's going on behind the scenes, and it's all just magic black box. I don't like black boxes because I'm getting into such high level stuff, such difficult coding challenges, that the more black boxes I deal with, the more I can literally like run into dead ends and stuff and just great deals of frustration. But as I start to strip away a lot of the black boxes by just coding the black box myself, the more all confusion falls away. The more I'm like, wow, I get it. I mean, I really get all this stuff. And it just makes you more powerful as a programmer. I mean, all restrictions and limitations begin to fall away. You can really utilize the hardware and utilize the operating system to the fullest the more you understand the deeper things going on. And the more you use higher and higher level libraries, and libraries built to interface with other libraries, and then libraries built to interface with other libraries, built to interface with other libraries, built to interface with other libraries, you're like 6 libraries removed from what's actually happening. You have no clue. And I hate it. I hate that. So, based on that, I was watching this really cool series, which I watch off and on over the years. It's called, so a YouTube channel called Molly Rocket, and he has an introduction to C on Windows series, and then he has a second series called the Handmade Hero series, and day by day, each day is like a 2-hour coding session. He implements everything from CPU concept overview to setting up OpenGL to, he creates his entire game engine from scratch, and he created a really advanced 3D game, all from scratch on Windows, and that's kind of goes along with my philosophy. But one thing he said in this most recent video is that his initial plan for that game was to just make it a 2D game, and he was going to do it without using OpenGL, without using DirectX, just using the Windows API. He was going to make a 2D game. And I was like, whoa, I never even thought of that. How cool to not have to use OpenGL or DirectX, let alone all these other graphics libraries, to just know enough about the Windows API that you make the entire graphics yourself. That blew my mind, because here I am going through the OpenGL Red Book, which is like a huge book where you like learn how to use this API. And so you're spending so much time learning how to use an API with having very little understanding of what is even going on behind the scenes. So you're actually not, it's like you're learning, but you're not really understanding much of anything because you don't know. They're not teaching you how the API works or how you would reproduce the API. They're just teaching you how to tap into an API that hides all the actual work away from you and keeps you in the darkness, so you don't really know what's going on. And so you don't really learn how to interface with the graphics card or anything. Yeah, you're very high level, and that limits you. And one thing that I see myself more and more being drawn to, realizing is this thing I need to know how to do, is how to interface with graphics cards and harness their power for use for like computer vision. Learning how to optimally and efficiently max out your use of the various cores of a processor in your program by making it multi-threaded or multiple instances of the program that are each running on a different core of the processor, various different ways you can maximize your use of the processor in order to use that hardware acceleration or whatever, in order to max out what the computer can do to multitask so that you can quickly do all the stuff you need to do and make your program faster and faster. I've gotten fairly good at that as far as using way more threads and stuff, and I just do it by launching more instances of the executable, and each instance has its own job, and each instance runs at the same time as the other instances, so they're all doing little jobs, and so the operating system can divide that up amongst however many cores and threads it needs to do that, and I just create a bunch of executables all running at the same time. That's all I have to worry about. So that solves it, and I'm really maxing out the processor usage that way. I believe that's how it would work. Um, so how can I take it to the next level and actually utilize the video card to do processing for me? Like to actually calculate things. I'm kind of in the dark on that. I really don't know much about that. I've saw little hints that there are like libraries that can help you with that and stuff, but I don't even, it's just all very murky to me. I don't get it. I've just seen some code that was said to be doing something like that, but I didn't really understand what was going on. And I haven't looked into it much at all. I've just only recently found out that's something you can do, and as I thought about it, I was like, that's probably the key. That's probably, I mean, video cards are like their own computers. Like, they can be faster at some stuff even than a processor is. And so if you can learn how to make the video card calculate and, you know, just be a number cruncher or whatever, it can do that even better than a processor, even faster. So I want to like somehow get into understanding how you would actually do that. How do you harness this beast called a video card and make it your slave and make it help you with some of the heavy legwork of computer vision and stuff like that? So I was thinking, wow, this idea of creating graphics without using OpenGL, which was the library I chose. It was between that and DirectX. I was like, OpenGL is more portable, whatever. I think I'll go that route. And I actually managed to find OpenGL that was compatible with my IDE, which is like 15 years old, but I want to stick with my IDE. I don't want to change because I know this IDE. I'm comfortable with it. I think I shouldn't be forced to change IDEs. Why should I be forced? No, you can't make me just arbitrarily be forced to against my will. I love this IDE. I have no reason to change it. I'm comfortable with it. I like looking at it. It actually brings me comfort looking at the IDE and feeling nostalgic. It's like visiting an old friend. I've spent literally thousands of hours looking at this IDE, this GUI, Dev C++ 4.9.9.2. Thousands of hours. And it takes me all the way back to my early 20s when I first started coding with it for video game botting. It's like, yes, that's where I want to be. I want to be someplace familiar, someplace I've had a lot of success at. I don't want some fancy new IDE where I feel like kind of foreign. I feel like a visitor, a foreigner. This IDE, I feel like it's my home. Imagine if somebody told you after you lived in a home for 15 years, you need to leave your home. Nope, you don't get to stay here anymore. Pack up your crap and go. It's like, no, that's not cool. Nobody would like that. And that's how I feel that kind of the way of how software is, that's how you're forced to be. It seems like they try to force you to upgrade IDEs. I'm not saying like there's a they conspiracy, but just the way everyone creates new libraries and stuff, and then those new libraries aren't backwards compatible with old IDEs, so you're being told, like by ChatGPT, I'm always being told, hey, you need to use a more modern IDE so you can use this and this library, and then you can't like get the old libraries because they're not online anymore, or you have to like hunt them down, like earlier versions of modern libraries that are compatible with your older IDE because they came out around the same time period. So that's like a workaround. But if I don't rely on a bunch of libraries, if I just code everything myself, I don't have to worry about that type of issue anymore. And so that's a huge upside to just coding it all myself and not using libraries. The only libraries, ideally, if I could have my way, I would use one library, and that's the Windows API. That's it. The Windows programming interface. That's all you need. Everything else built on top of that, and it's meant to make you not have to do the work. But when you are lazy and you don't do the work, you tell other people to do the work, then you don't gain the learning and understanding of what's going on that you would have gained if you had done that work. Now I get it, like if you just want to make a video game as little time invested as possible, you don't really care to understand much, and you're not trying to do something that's really revolutionary and really difficult and challenging like I am, creating the singularity and creating your own computer vision, your own AI, your own speech recognition, your own voice synthesis, your own telegrammetry. I'm trying to do stuff myself that people expertise in just one of those, and I'm trying to do them all. And so I need to be like a beast. Not spiritually speaking, a beast is an immature, unspiritual man that lacks self-control. I'm not saying that kind of beast. I need to be like a savage. I need to be like an expert at like all kinds of low-level stuff and understanding how computers work and how to program like at a low level in order to make it way easier on myself in the long run to really create optimal, efficient software that can handle these types of really challenging tasks that I'm taking on. I'm loving taking them on. It's fun, but it's like by me cutting out OpenGL, cutting him out, the middleman's gone, and I make my own OpenGL. We'll call it Larry GL, the Larry graphics library. Now, well, step back. I mean, that's like scary. You made your own graphics library? Dude, you're an expert. Like, you know your stuff. That's like, whoa, this guy knows calculus. This guy gets it. Like, wow, he knows how to do all that stuff. He knows how to code all these algorithms at low level stuff. Yeah, that's a guy that can do computer vision. That's a guy that can like make revolutionary graphics. That's a guy that can have his AI actually build a video game. Like the AI builds the whole game, designs the game, makes all the models, designs the gameplay, designs the graphical interface. You just tell the robot, make me a AAA game, and the robot makes you a AAA game. If you want to be able to do something like that, you can't be a script kiddie. You can't just use other people's libraries and stuff. You need to know how to do all of this stuff from the scratch. So what I'm so excited about, because it's so funny, is I'm planning to make my own graphics library, 3D graphics library. Except it's not even going to be a library. It's just going to be part of my main C++ program that I do everything else in. It's not even going to be a separate, it's all in one file. So no one can ever use my library but me as well. Which makes it even more funny. Who has one file? You press F9, it compiles and runs it, and it's a video game, it's AI, it's everything in one. And it doesn't even use a 3D graphics library, but it has 3D graphics. Like, that's so silly. I mean, technically, I decided to make my own operating system as well, so this is like right in line with that. But even the idea to make my own operating system is like so funny and awesome, and I can't wait to get started on that again, or continue my efforts in that area. I already made a nice progression on it, and I look forward to doing some more. And what's cool is like you can create just primitive, super simple 3D graphics library or whatever. Your implementation could not have Lambert and Blinn and all these fancy calculations for like certain types of textures. You could just have one texture and one shader and one lighting calculation thing. It's just super stark shadows, no blending, no like the light can pass through a leaf of a tree and be partially limited, so there's a light shadow that's formed. You could just have everything be just pitch black shadow. Just keep it like super basic. And then like, you've got 3D graphics. And then like you can add a little bit over time, over the years, hey, I'm gonna improve on the lighting algorithms. I'm gonna make it a little more advanced, or I'm gonna add particle effects. And how cool would it be to like not just learn how to do the library call to make a particle effect or download Unreal Engine and click add particles, but like to code, like what even is that? To code particle effects. Like, this is blowing my mind. It's like so interesting. And learning OpenGL, it's like I felt like I'm getting close enough to where it's kind of interesting, but I still don't really know what's going on. I got like, did I get like a box on the screen? I got it to rotate or something. It was like a bunch of commands to initiate the library, and then a bunch of commands to like make the box and then tell it to rotate. I didn't know what's going on. And then they're gonna like tell me how to tell the API how to like change the lighting, the camera location. I still have no idea what's going on. But for me to be able to create my own text file with those coordinates and then like load those coordinates into an array and then calculate where the vertices move in 3D space from a central pivot point, and then like somehow convert that 3D idea with light effects from a certain place in the scene to like change the colors partially to a lighter color of the different pixels on the box, and then like turn that to a 2D image and then have that copied onto the display context of your window, replacing what was the previous image on the window. That is all hidden from you in OpenGL. You have no idea what's going on as far as that. And that's the stuff that's like, yeah, that's what I want to know how to do. That's where the magic happens. That's where the understanding happens. That's where it's like, I get this stuff. And that would help me a lot if I knew how to do that for doing like photogrammetry, which is where you take a bunch of pictures of something in 3D and then you convert that to a 3D object based on just photos of something in real life. A program can convert that thing to a 3D object in software. And that's what I want to be able to do, because then you could have your AI watch a movie and reconstruct every scene down to the color, the shading, the shadows, everything of that scene. You could make that movie scene. You could tell the AI, make this movie, and it would like make the whole movie in 3D. It'd be able to reproduce it. And then you could like pause the movie and like just start walking around the scene looking around at the movie from every angle, because it reconstructed the whole movie, like everything. So you could like see what's behind Willy Wonka. You could like stand in the room Willy Wonka's in, and you could take a tour of the chocolate factory, because your AI like made the chocolate factory. You could actually explore it as a video game character and run around the chocolate factory from the movie scene. Like, that blows my mind. Like, that would be so cool. And then you could make that like a video game level, the Willy Wonka's chocolate factory level, and they'd have to like fight the fight the Willy Wonka minions, whatever, Oompa Loompas. You have to fight them to try to escape the chocolate factory. Like if you pretend the Oompa Loompas and Willy Wonka all turned evil and you have to escape the factory, you could make a video game like escaping Wonka's factory could be the name of the game, and you would have to like escape, and you could have your AI like pretty much like take all of the scenes of the whole movie and reconstruct the whole factory as best as it can judge, and then like you start out in some area of the factory and you have to escape and they're all trying to kill you or something. That would be like, you know, I'm not saying it has to be that, but like there's so many video games that could be created or generated through AI, just auto-generate the whole game based on something like that. So it's just like, man, you can't do something like that unless if you know what's going on, like as far as like a little deeper than just, oh, I'm a script kiddie using OpenGL because I followed a tutorial online. No, like you need to know how to make OpenGL yourself. So that's what I'm planning to do, and that's the announcement. So that's what I'm actually going to start right now. You know, I might only work on it for like 4 or 5 hours or whatever here and there. Eventually, you know, we'll have something. We'll be able to actually, it's like for me to just put a cube onto the screen and make it rotate that I coded myself, and somehow like ChatGPT walks me through how to do that. That's 3D graphics right there that I made myself, not using a 3D graphics library. That alone would just blow my mind. It's like we'll start baby steps, and then we'll be working our way more and more, fully understanding now what's going on, and just adding to it. That's the fun part. Like, the journey is so fun, and just the power of being able to do it yourself. I mean, isn't that like the whole thing of my YouTube channel is like, do it yourself? Like, when you're getting ripped off by car mechanics or whatever, and you're like, I'm tired of getting ripped off, I want to learn how to fix my own car to save a ton of money. And then you learn it, and you're like, wow, that felt so good to be able to do that myself. And then, like, you know, I've always thought, like, what if what if the whole world, we lost all technology? We'd have to have some guys that know a lot of stuff to like rebuild civilization. I was like, I'd like to be one of those guys. I've thought that like since I was a kid. Like, man, how are movies made? Like, how do you build an engine? How do you actually turn ore into metal and then make an engine from that? Like, how does that? Like, I wanted to learn all kinds of stuff, and that's kind of still what I'm doing as an adult now. And I have the luxury of doing that. I have the time luxury of doing that. So, this is the type of cool stuff that I'm able to do because I work from home, and I'm not after making a ton of money. I'm after just having a little less income but more time. I could trade time for money, or I could keep my time and use my time to learn really cool stuff and get really good at a ton of things and be a jack of all trades. Except I say master of all trades because that's funny. I prefer to call it that way because calling it a jack of all trades, master of none is like a pessimistic way of saying, oh, if you don't specialize, you're a loser. That's never going to be a master of anything. And that's like, so basically you're saying anybody that's a Renaissance man is a loser. And so you're criticizing anyone from trying to learn a lot of different fields. Why do you have to make it so negative? I don't like that term, jack of all trades. I prefer master of all trades. It's like a pushback against them trying to twist you trying to be a well-rounded, a competent person at a lot of different fields. They want to make you feel bad for it. So no, I don't like that type of terminology. So that's what I'm doing. I'm so excited about it, and I'm about to start it right now, boys. Oh yeah. The irony is I'm going to use a library to create my window. But besides that, we're going to try to do everything from scratch. So let's get it going. I'm super excited about this. This is such a great idea. It just came to me for the first time today. I'm like, oh, I've got to do that. I've got to make my own 3D graphics. Forget OpenGL, forget DirectX, all these fancy names with their huge books of documentation. I'm over all of it. I just will make my own. It's going to be great. This is going to be so fun. And then, like, let's say at some point, like, let's say I wanted to, like, use OpenGL for something. What if I could, like, make something in OpenGL and then like feed my graphics library interlacing into that, like intertwine the two? Like, I'd be able to do something like that. I wouldn't be just beholden to their stuff. But I don't even want to do that really. In fact, let's make a commitment. We're not going to do that. We're not going to, because we'll call that copping out. We'll call that selling out. We'll call that wimping out. We'll say, if you have to use anything from a graphics library, besides like looking at source code to help you with some algorithm, maybe that's fine. But if you have to like use somebody else's code, then you're like taking a shortcut, and so that will be like penalized in our mindset. That's like anytime you use somebody else's code, for the most part, you're cheating yourself out of learning and out of becoming more capable and out of the fun of just learning how things really work at a much lower level. That's what you're robbing yourself of, and you'll never be the programmer that you could have been because of that. So yeah, we don't want to do that. Okay, so To even take this on requires me to like really step into believing like anything is possible. Like that's what I got excited about when I first learned to code. As I was like, you have to believe with this code you can do anything. Anything like that code can do. In other words, I'm not saying like anything, but like anything code is capable of doing, you can do that with code. And that like unlimited aspect of code is what makes code exciting. Like, and so that's why I'm excited because it's like this is doing with code what makes code exciting. It's saying, hey, I'm not limited. I should be able to do this if I think it would be interesting and educational and helpful to me, even to start to pull away kind of the blinders of what it means to be or what it means to use a graphics card and what it means to like make 3D graphics, like to really get it. That's what I want. I want to get it. I want to get what's going on. Like how is this even working? I hate it even just OpenGL as low level as you may think that is. It's way too high level to really understand what graphics even is all about. You don't know what's going on that much. And the fact that it's so complicated to even use the graphics library means like you're investing so much time learning how to use their graphics library that you could have been investing that same time into learning how to make the graphics library, like how to make the graphics, rather than like just tapping into something that magically makes it. You could have been like making it. And probably in the same amount of time it would take to master using OpenGL, I could have actually mastered making very primitive, simple graphics myself from scratch. And then being able to be unlimited, like your skills, your understanding of computer graphics just went through the roof by being able to even do that. And yet, had you invested the same time, you'd have just known how to really well use a library. It's like, no, man, don't waste your time trying to learn to use a library when you could have used that same time to become the library. Like the library's in your head rather than just a quick download and you have no idea what's going on when you use it. That's how that's how to really make this happen. Ah, man, I feel so good doing this. This is such a great idea. It's great, and it's also like, it's great also because it's like madness, like torturing yourself. Actually, like the tediousness of it all. The fact that it's going to take way longer, the fact that it's going to be way harder, the fact that it's a bigger challenge, the fact that you're going to learn way more, the fact that it's going to open up so many opportunities for you to really understand how to interface with and utilize that beast of a tool, which is a graphics card, and how to like calculate with that graphics card and how to tap into that those calculation abilities to help your AI projects. That all makes this epic. Such a cool idea. So neat. I'm just, oh man, I'm so excited about this, guys. Hi, Devator. And this forks off from my main program because of this to this new agenda. That's the fork. So now we can create that whole section for ourselves. This is all my OpenGL code, which we are abandoning, I hope. I'll leave it in there, just because if I ever wanted to pick up my OpenGL efforts again, I can. But we're pretty much intending that just to be a simple demonstration, we'll say, of how OpenGL, very basic initiation works. And that's worth saving just for the heck of it, just in case. But ideally, and my intention is, we're never going to return. We're never going to look back. We're going to make our own graphics. That would be like a fallback plan if this was taking too long, or I just couldn't get it, or I just felt it wasn't the best use of my time and I just wanted to get things moving quicker. Things can change. It is possible. So I think it's nice just to keep it as a backup plan, but that's not our intention. Our intention is, let's make this happen. Let's do it from scratch. Be getting rid of that. Really just goes to show you I was learning learning OpenGL and I just read all this stuff and I have no idea what it's even talking about. And that's the problem with using, a high level graphics library. What is a frustum? What's an ortho? I guess a viewport, this kind of makes sense. What's a translate F? What's a matrix mode? I'm calling all these commands and no one even tells me what it is. I'm in total darkness. I have no idea what the heck's going on. I'm copy pasting code. Following the tutorial guide, the OpenGL handbook, the red book, and I have no clue what's happening. I got a triangle to spin around on my screen. I was none the better for it. I copy pasted everything my way through it. And I'm reading probably descriptions in the red book, maybe some high level explanation of what's going on. I don't really know. It's not helping me much. I'm not learning much. And I can't even remember because I have no idea what's going on. So it's just, the whole thing is like an exercise in futility. If I actually made my own triangle and loaded it from a file and rendered it myself with all my own code, I would learn a ton. I'd know what's going on. And I would be like actually, learning valuable stuff that I can remember. So that's how this is going to be so much better. I'm so glad we're going this route. This is awesome. All right. The possibilities, guys. Here's our practice window. It all works, moves around, and we're going to put graphics on here. The possibilities are endless. Oh, we got this, boys. We made a window. That's something. Granted, I had to use library to make the window. Didn't have to, but this library is so small. It's just called WinBGIM, and it just gives the init window command. You can just say that, and then the window's made. And that's one library. I don't mind, because creating a window is actually not that hard to create a function that does it. It just is like a huge bunch of options you set up. And I didn't want to create even one function at the time I made this. That was just a rule I had when I first started working with making a window. That was kind of something I wanted to stick to, never making a function ever. And so I didn't want to go through the headaches of making a window, but I think now I could. So eventually I will make my own init window type function type of thing. And then we can get rid of that particular library, because we're trying to get as library-less as possible, where we're just using the Windows API. That's the goal for the most part, is just to stick with just the Windows API. That way we're really maximizing understanding everything going on. So this is cool. Looks great. Now to create a triangle. Wow. Teach me, ChatGPT. Show me the way. I'll just scroll through this, guys, so you can see kind of how I started with ChatGPT. What would be involved to code 3D graphics in a 3D program and a C++ program without using OpenGL or DirectX for Windows? Is this feasible to just code the graphics directly with no 3D graphics library but only using Windows.h? It is technically possible to write 3D graphics code in C++ without using OpenGL or DirectX, but it would require significant effort to implement all of the necessary functionality. Without the graphics library, you would need to implement algorithms for 3D geometry, shading, lighting, rasterization from scratch. This would require a deep understanding of linear algebra, calculus, and computer graphics theory. Using only Windows.h is not sufficient for 3D graphics programming, as it only provides basic functionality for creating, manipulating windows and user interface elements. You would need to use additional APIs or libraries to interface with the graphics hardware and access low-level functionality such as frame buffer access. Overall, while it is possible to implement 3D graphics without a graphics library, it would be highly challenging and time-consuming. What library is something like BitBlit? Oh, where was that, WinGDI? What the heck is WinGDI.h? That's important to remember, guys. WinGDI. I think that's going to be like what we use, I think. That's the Windows stuff we need. Oh, look at that, GDI library, so he's already on top of it. You know what? You don't actually ever move the camera. You just move the world. So, like, if here's the world and here's the camera, if the world does this, it looks like the camera moved, but really the world just moved. The camera never moves. So if the camera seems to be moving through the world, it's actually the world just passing out of the frame of view. The camera never moves. That's how I'm going to think about it. That's my preference. It takes away one, complicated element that way, if you think of it like that. I'm picturing, guys, like a 2D box moving around, and then that 2D box, like, its vertices change, and then you'd see it, like, from a different perspective. And then if you, like, rotated it, like, if you, like, moved it down and then rotated it like this, it would look like your camera just raised up and tilted down. But it didn't. The camera didn't move, but the box just moved, which made it seem like the camera moved. And you just had to calculate all that using, like, calculus or whatever, like, where all the coordinates changed. And then, like, I then thought, like, whoa, what if, like, my webcam took a picture of my room and then it, like, recreated every object it saw in 3D, and so then it could identify and recreate in 3D everything in the room and rotate everything around from every angle based on researching online each object after it identifies it and all the angles of the object. It could actually predict what all sides of the object look like from photos it finds online of a said object, like on Google image search, and it could index those and then get an idea of every angle of the object, and it could reconstruct it in 3D that way. And so it would have a 3D model of every single object in the room, as well as an idea of the weight of every object for the purpose of the humanoid robot being able to grasp and pick up the object. Then, for the humanoid robot, we could have a whole physics engine and 3D rendering engine to create the whole room and then create a humanoid robot in the room and then simulate the robot going through the room, his balance and the physics of his movement and moving through the 3D environment, and him reaching out and grabbing things, and simulate all the commands that would be sent to the lower level, microcontrollers that control the various motors. We'd be able to simulate sending out all of those commands to those, and the motors moving in accordance to move all the muscles and everything. and we'd be able to pretty much like implement a top-down workflow for the whole movement of the robot, the balance of the robot, the physics of the balance of the robot, actually predicting how he's going to interact with things, how much force he's going to put into things, all the motor movements to make all the movements of the joints, and all the inverse kinematics involved, and him to be able to grasp and pick up objects and carry objects and stuff. And we could then, just by walking through the house with the webcam showing everything, we'd be able to create a map of the entire house in 3D just by a walkthrough. Just a quick video, he'd be able to map the entire house and then be able to do simulations of all the things on his to-do list, like doing the laundry, cleaning, everything. We'd be able to simulate it all. So that by the time I actually create the robot, we already have all the code in place. And pretty much I switch the robot on, and all the high-level code is in place for motion planning and stuff. And it's just a matter of then integrating that into the various microcontrollers to execute the movement of the motors and then send back the feedback for verifying that everything's moving according to plan to all the higher level processes that I just described, so that it can then continue planning out its motions, making any adjustments as necessary, like collision detection or whatever, or speeding up the motion to catch up with what it needed to be because it was a little slower than it thought or whatever, and adjusting in accordance with that to make the arm move quicker or the leg move quicker or whatever. And so little adjustments and micro tuning to cause his motion to simulate humanoid type of walking gait and posture and whatever. And so we can actually do a ton of simulation work, and I'd be encouraged to do so because I'd be like, learning physics and learning 3D graphics, all that I'm coding from scratch, and that would like be my project for, how, like, why that's useful to me and how that's going to help me with the humanoid robot. And then the photogrammetry aspect of that, being able to take a video of an environment and convert that into a 3D environment that can really be interacted with. That type of technology is called photogrammetry, and that will be how I'll have the robot AI make video games and stuff, by converting 3D like movie scenes into like actual 3D universes that you can interact with and be a character within that movie scene or whatever. So it can like just watch a ton of movies and stuff to get information like about a Middle East setting, and then it'd be able to use that, all the footage from biblical videos or whatever, to make the David game for like a Bible game. It'd just watch a bunch of movies and it'd be able to get all of the in-game assets. So you wouldn't need an asset store like Unity Asset Store. It would just watch a bunch of movies and be able to produce the assets using the movies to create the textures, the 3D models, everything. It just pulled that off movie still frames. And then it'd be able to reproduce that in 3D just by researching online more about what does a pot look like from every direction, be able to make a pot based on an image of a pot from a still frame of a movie that it saw, and then it converts that image of a pot into an actual 3D pot with the texture and everything, all automatically. And it'd be able to do that for everything in the movie scene, so it'd be able to create whole environments and everything just by watching YouTube videos and movies and stuff. And that's super advanced AI. That's amazing. That's awesome. And so that's what we'd be able to do. That's called photogrammetry. It's photogrammetry. It's like image recognition combined with photogrammetry. But the photogrammetry, normally people have to take images of an object, like 20, circling the whole object. But this would be better in that it would be using Google image search to pull up all the different angles of that type of object, and like intelligently integrate that information into creating a 3D object. So you wouldn't have to like manually yourself take a camera and take like 20 photos of every object you want to create for an asset. This would like just take a still frame of a movie, pull and identify everything in the still frame, and then use Google image search to like get way more visual information about every item that it saw in that movie by name. It'd look it up and look for different angles and pictures of the item to learn more about that item, and then it'd be able to use that as its photogrammetry background information to be able to reproduce it in 3D from all angles with pretty high fidelity. So that'd all be automated, and then be able to do it on a massive scale, all simultaneously producing entire scenes very quickly. Whereas if you hired a team of 3D artists, that would take months of development for them to even be able to reproduce that scene. But this would be able to be done in seconds by an advanced AI. So that would make the process of creating a video game or creating a movie or a cartoon super easy. So easy that my AI will actually do it. It'll create video games and cartoons, whatever, from scratch. I'll just say, hey, make a video game about this, and it'll just make the whole game. Boom. Who knows? Maybe instead of a AAA game dev team spending years to make a video game, my AI would be able to make the same video game in 5 minutes. Okay. That'd need a lot of processing power to do that in 5 minutes, though. So it would need a lot of simultaneous computing by like a huge like a huge amount of laptops, which we have a ton of laptops behind me. We'd have all those laptops working full speed, working together, all of them taking some little part of the processing load to do that at higher speeds. It'd be like having a large team working together at a high speed. So that's where I'm glad I didn't throw those laptops away. We'll be able to use them for something like this to really speed up like super hard AI tasks. It will be able to employ those through socket communications. It will say like, hey, I want you, laptop number 3, to work on creating photogrammetry of this pot from this still frame. You, laptop number 16, I want you to work on photogrammetry of this car from this scene. And so they'd all work together, delegating and outsourcing and working together to do this at a very higher speed. The idea of like seeing my own house, my own room, whatever, reconstructed in a 3D environment in a window, but it's all fake, but it looks real, and then like it's accurate measurements and everything, and then like have a fake robot like interacting with my room. That would be the ultimate like testing for like making the humanoid robots code before the humanoid robots even built yet. And a lot of companies do that. It's called like simulation. You work in a simulation first, and then you test it on actual hardware. Boston Dynamics does that all the time. It's part of their workflow. So this will all feed into that idea too. It's going to help me with all types of generating of media and video games and videos from YouTube. I'll be able to use the AI to do all that stuff, and also use the AI to do the. I mean, they all go hand in hand. It's like these technologies all work together. So all the things I'm wanting to do are all related and overlapping. So it's efficient to do them all together. Yeah, ChatGPT I'm using as my teacher, basically. I know that failed me in the past with OpenSSL. I mean, my wait no, with my SFTP client, it could not direct my steps properly, but we're trying it again. Hopefully, it will be better this time. Maybe I don't know, but we might end up having to like pull in a 3D graphics library and just see what's what that way. I think he does a pretty good job, but man, when he starts telling me false stuff, that's one thing that's kind of bad though. I'm streaming. They're not up. Do you need me for something? Oh, thank goodness you got home.
Just real quick.
I'm streaming.
Just real quick. Tell me why she's put $20 worth of lotion on her hair.
Let go! You sweetie!
$20 worth of lotion.
You put $20 worth of lotion on your hair, you sweet pea! You funny little baby! You need some of that lotion too, don't you? You keezer!
Oh my god.
You little
Bye.
bitty!
Say bye-bye, Daddy. Love you.
You look so cute, Bobby! You too, Wolfie!
That's it.
That's pretty cool. So, like, let's say like 1 inch across in your texture and 1 inch down would map to like some coordinate on your 3D model, and that's where the texture starts. And then it just will wrap that around the 3D model somehow. That makes sense. He's trying to trick me into using DirectX. What an idiot. I'm gonna start like asking ChatGPT questions to guide me to Google search. That way ChatGPT gets like a cooldown because I notice he complains and gets slower if you like ask too many questions in a row. So I'm gonna like go back and forth, like kind of have Google supplement ChatGPT. What are you doing? The babies are crying.
The big baby told me to look for her phone. She sent me downstairs to look for her phone. And then the other little lady started crying, and I'm like, oh, I might as well just take a 5 minute break. Do you know where her phone's at?
What?
Do you know where her phone is at? Do you have any idea?
No.
No?
And I need to concentrate right now.
Oh, man. Oh my god.
However, this version of the CUDA toolkit may not be compatible with other packages, which we also would like to install in this environment, for example PyTorch. So let's try something else. Instead of installing CUDA first, we will begin by installing PyTorch. We can do this by typing conda install -c PyTorch. And look at that. So it seems that by installing PyTorch, we are also automatically installing the CUDA.
Break out your 3090s, boys, because today we're mining some Bitcoin. No, just kidding. Today we're talking about NVIDIA CUDA core programming. The reason I want to talk about this is because I think it's a really interesting topic of discussion when it comes to how to use different parts of your computer to do different things. So why would we do GPU programming, right? So GPUs are able to do extremely high throughput parallelized processing. Now this is in comparison to your CPU, which is designed for serialized execution in a low latency. Break out your 3090s, boys, because today we're mining some Bitcoin. No, just kidding. Today we're talking about NVIDIA CUDA core programming. The reason I want to talk about this is because I think it's a really interesting topic of discussion when it comes to how to use different parts of your computer to do different things. So why would we do GPU programming, right? So GPUs are able to do extremely high throughput parallelized processing. Now this is in comparison to your CPU, which is designed for serialized execution in a low latency fault tolerant kind of way. And the reason this happens is because of the way that the CPU and GPU are designed. If you look here on the left, you have a CPU and it has maybe 8 to 16 cores, and a core consists of a control unit and an ALU, right? The control unit does the logic control and the ALU does the math, and it has cache where it can very quickly look up memory and data as it needs. It's meant to be serialized and very fault tolerant. A GPU, on the other hand, is meant to do things extremely fast and extremely parallelized. They're designed with parallelization in mind. And that being said, the modern GPU, I think the 3090 has 11,000 cores, right? So if you are able to do data processing in a parallelized way, you want to be using a GPU and you'll get way faster results out of it. So with that being said, what problems are good for a GPU? Like I said before, any problem that can benefit from mass parallelization is good for a GPU. So for example, the common example used when talking about CUDA core programming is scalarize a large set of vectors, right? So we're gonna run through this example using the CPU model. So we have the vectors over here, 1, 2 is our first vector, the left column is A, and the middle column is B, and then the destination is gonna go into C. And we have up to n number of vectors. How would we do this on a CPU? On a CPU, we would say for int I equals 0, and we would just iterate over this loop, and we just add them up, right, until we get to the very end. And what would actually happen in execution is we would have a very linear look up vector element A, look up vector element B, add it into C, and do that for the first, second, and up to nth execution. But what we actually over time get is we incur a cost in we just E, and parallelization is good for a GPU. So for example, so with that being said, what problems are good for a GPU? Like I said before, any problem that can benefit from mass parallelization is good for a GPU. So for example, the common example used when talking about CUDA core programming is scalarize a large set of vectors, right? So we're gonna run through this example using the CPU model. So we have the vectors over here, 1, 2 is our first vector, the left column is A, and the middle column is B, and then the destination is gonna go into C. And we have up to n number of vectors. How would we do this on a CPU? On a CPU, we would say for int I equals 0, and we would just iterate over this loop, and we just add them up, right, until we get to the very end. And what would actually happen in execution is we would have a very linear look up vector element A, look up vector element B, add it into C, and do that for the first, second, and up to nth execution. But what we actually over time get is we incur a cost in looking up and running the actual program that has to do this data lookup and mathematics. And over time, it becomes less efficient to do the serialized as opposed to using multiple cores. And that's where the GPU comes in. The way we do this on a GPU is instead of serializing it and doing it, one by one by one, we could write a function that is meant to be used in a parallelized fashion, and we would assign that function an index for every vector that we have. And we'll figure out where that index comes from in a second. It's a pretty cool way that the CUDA framework set this up. But basically, we would create this function, and we would execute this function in parallel for every vector. And again, that I, the index we use to index into our vectors, would come from the CUDA framework. And as you can see here, our execution timeline, right, how long it takes to do this gets cut by, in this case, 3. Your gains would go up per the size of your n, right? So if your n is serialized out to 1024 elements, if you could do this in complete perfect parallelization, so 1024 cores, you would have a speed up of 1024x, right? So how do we determine where this I comes from? I know this graphic's a little complicated, but it's actually not that bad. So the way the CUDA framework is designed, it's meant to take away the complexity of parallelization. So the abstract away from the CPU to the GPU is what's known as a kernel, right? And a kernel consists of these things called grids, and then grids consist of blocks, and then blocks consist of threads. And what actually happens is when we execute a kernel, we tell the GPU how many grids and blocks and threads we want to have in our program. So for the case before, where we have this n value, we can tell the GPU, hey, instantiate n number of blocks for this program. And within that function, we will actually get an index value that will represent the number of the block that we're in when this program executes. With that number, we can index into the array, and the block will know which index to go into and do the math for you. So what we're gonna do now is we're gonna actually go into Visual Studio. I'm gonna show you guys how to set up the CUDA core framework. I'm gonna run you through this very example, and we're gonna do it in a way where NVIDIA parallelizes the problem for us and does it way faster than a CPU could. Let's get into it right now. Okay, so I'm going to assume that you guys already have.
So now that we know what OpenCL is, how do we use it? Well, the easiest way I've found is to just download one of the SDKs from the main vendors, AMD, NVIDIA, or Intel. I don't think it actually matters which one you choose, because I've got an AMD graphics card and an Intel CPU. They both support OpenCL. I downloaded the AMD SDK, and I'm able to run OpenCL file on both these devices. So once installed, they'll have a directory for the includes, which contains the header files, and a lib directory containing the library files that you just need to include in your IDE project. I'll be using Visual Studio on Windows, but I'm sure it's a similar process for whatever operating system or IDE you're using. So this is where I downloaded it. I just googled AMD SDK OpenCL, got to this page, and then clicked this hyperlink here. So this is where I don't think it actually matters which one you choose, because I've got an AMD graphics card and an Intel CPU. They both support OpenCL. And I downloaded the AMD. So now that we know what OpenCL is, so now that we know what OpenCL is, how do we use it? Well, the easiest way I found is to just download one of the SDKs from the main vendors, AMD, Nvidia, or Intel. I don't think it actually matters which one you choose, because I've got an AMD graphics card and an Intel CPU. They both support OpenCL. I downloaded the AMD SDK, and I'm able to run OpenCL fine on both these devices. So once installed, they'll have a directory for the includes, which contains the header files, and a lib directory containing the library files that you just need to include in your IDE project. And I'll be using Visual Studio on Windows, but I'm sure it's a similar process for whatever operating system or IDE you're using. So this is where I downloaded it. I just googled AMD SDK OpenCL, got to this page, and then clicked this hyperlink here, which downloads the SDK for Windows for both the 32 and 64-bit platform. Then after you do that, just open up your IDE. In my case, Visual Studio. Let's create a new project. Just call this one test. Next, I want it to be a console application. I don't care about precompiled headers or SDL checks. Make it an empty project, just because I don't care about all the other garbage it gives me. I just want one file. And I will just call this the same as the project name, just to make it easy for me. And so there's a few things you need to do. You need to add the include directory. Windows 32-bit. I don't care for this. Fuck. Do I make 64-bit? Yeah. Yeah. Just because who cares about 32-bit these days anyway? It's being phased out. I don't care about it. So go to the directory where the SDK installed. In my case, it's here, and I just want to add this include directory. Okay, that. Go to the link. and so it needs a dependency. And so it needs a dependency on the open cl.lib, and that is located in the same place. Oh, it doesn't remember the last place I was at. Never mind, just find it again. Lib, and that's 32-bit, it's 64-bit. I'm building 64-bit, so I want this one. Okay, should be all you need to do. So hopefully it should be able to find CL, yeah. Now, so this header file is if you want to just use the standard OpenCL C API, but in my case I want to use the C++ API. So I'll do that, create a simple main function, and I'll just call something OpenCL. I think that should be okay. It's not giving me any warnings. Build that. So we get a few build warnings, but it was successful. That's good. I think these build warnings are because I'm using the latest SDK, which has OpenCL 2 support, and it's probably deprecated all these other things and just give me warnings about them. But there is a way to turn those off, but I can't remember the macro. Okay, I found give me warnings about them, but there is a way to turn the latest SDK, which has OpenCL 2 support, and it's probably deprecated all these other things and just give me warnings about them. But there is a way to turn those off, but I can't remember the macro. Okay, I found it. You just need to define this before you include this header file, and it should get rid of all the warnings. Cool. Now that we've got OpenCL working in our IDE, let's look at some of the terminology that's going to be used throughout this series. So now that we know what OpenCL is, how do we use it? Well, the easiest way I found is to just download one of the SDKs from the main vendors, AMD, NVIDIA, or Intel. I don't think it actually matters which one you choose, because I've got an AMD graphics card and an Intel CPU, they both support OpenCL. I downloaded the AMD SDK, and I'm able to run OpenCL on both these devices. So once installed, they'll have a directory for the includes, which contains the header files, and a lib directory containing the library files that you just need to include in your IDE project. I'll be using Visual Studio on Windows, and I'm sure it's a similar process for whatever operating system or IDE you're using. So this is where I downloaded it. I just googled AMD SDK OpenCL, got to this page, and then clicked this hyperlink here, which downloads the SDK for Windows on both the 32 and 64-bit platforms. And after you do that, just open up your IDE. In my case, Visual Studio. Let's create a new project. Just call this one test. So there's a few things you need to do for this. Fuck. I mean, who cares about 32-bit these days anyway? It's been phased out. I don't care about it. So go to the directory where the SDK installed. In my case, it's here. And I just want to add this include directory. Okay, that. Go to the link. And so it needs a dependency on the opencl.lib. And that is located in the same place. Oh, it doesn't remember the last place I was at. Never mind, find it again. Lib. And that's 32-bit, 64-bit. I'm building 64-bit, so I want this one. Okay, should be all you need to do. So hopefully you should be able to find, see, oh yeah. Now, so this header file is if you want to just use the standard OpenCL C API, but in my case I'm going to use the C++ API. So I'll do that. I'm going to use the C++ API. Okay, so I'm going to use the C++ C API, but in my case, just use the standard OpenCL C API, but in my case, I'm going to use the C++ API. So I do that, create a simple main function, and I'll just call something OpenCL. Just use the standard OpenCL C API.
Doesn't even have the CL include thing. It says C drive program files times 86 AMD app SDK slash 3.0 slash include slash CL.h. We don't have that. My include just has that. There's no CL. That's missing. This is completely wrong. It doesn't have what we need at all. This will not work. So, quick editor's note. Um, when you install the SDK, it allows you to choose where you're going to install it. I chose to install it in my dev C++ directory under a folder named OpenCL, which I created in there, and I installed it into that folder. But it installed only all the example programs in there, as well as some include files related to the example programs. But then it created a separate directory, unbeknownst to me, in programs C drive program files times 86 slash OpenCL or whatever. So it created more than one OpenCL distribution folder directory on my system, only one of which I set up, and that was mainly example code. And then the other folder had the actual library that we actually need to link to our dev C++ IDE, and then from there we can add the library's library file and header file so that we can actually use OpenCL. So that was super confusing and unexpected that it downloaded two separate OpenCL folders on my system without even telling me. That's just weird. But that's what the issue was. I'll eventually figure that out though. But I'm just letting you know as the viewer, if you're confused right now like I was, that was what was happening, and I'll figure that out a little later on. What the heck? Whoa. I think this folder just has samples and then the libraries used by those samples specifically only, which are not libraries strictly needed or anything. They're just related specifically to the samples. Okay, I think I'm getting somewhere then. Uh, okay, so we want to go. Program files times 86. We find the SDK there. And then we put the bin in. Add. Library, same thing. This was the wrong place. That was where the example libraries for the sample programs are. But we're not even using those necessarily. So we're gonna again program files times 86, AMD app SDK, library, add, includes, same thing, let's just delete that one. And we'll go program files times 86, app SDK, 2.0, include, okay, click add. So now this is gonna add it. So when we installed the AMD App SDK, it installed a whole bunch of stuff right into program files. But it also installed stuff into my dev C++ folder I made for it. So it had two different distributions, which is crazy. I think this might work now. No such file or directory? Wait, what? Okay, now I'm getting confused. Why wouldn't it work? have to add the C++ includes, maybe? Now try? Oh no! That was it worked. Oh my goodness! Wow! 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 What in the world? Whoa! Whoa! I just learned to do something I've never done before. Whoa! Alright, let's update my notes. This is big. I think I'm really off to the races here almost here. Wow.
Is how do we use it? Well, the easiest way I found is to just download one of the SDKs from the main vendors, AMD, NVIDIA, or Intel. I don't think it actually matters which one you choose, because I've got an AMD graphics card and an Intel CPU. They both support OpenCL. I downloaded the AMD SDK, and I'm able to run OpenCL file on both these devices. So once installed, I'll have a directory for the include, which contains the header files, and a lib directory containing the library files that you just need to.
It's
include in
Windows
your,
7.
IDE project. I'll be using Visual Studio and Windows, but I'm sure it's a similar process for whatever operating system or IDE you're using. So this is where I downloaded it. I just googled AMD SDK OpenCL, got to this page, and then clicked this hyperlink here, which downloads the SDK for Windows for both the 32 and 64-bit platforms. And after you do that, just open up your IDE. In my case, Visual Studio. Let's create new projects. Let's call this one test. The objects. Name of the project's name. Just like add the include directory. Only 64-bit. Yeah. Because project gives me sort of one file. And I'll just call this the same as the project's name. Just make it easy for me. And so there's a few things you need to do. You need to add the include directory. Windows 32-bit. I don't care for this. Look. Only 64-bit. Yeah. Because who cares about 32-bit these days anyway? It's being phased out, I don't care about it. So go to the directory where the SDK installed, in my case it's here, and I just want to add this include directory. Okay, that, go to the link, and so it needs a dependency on the OpenCL.lib, and that is located in the same place. Oh, was it remember the last place? Sorry. Was that? And then run it again, lib, and that's 32-bit, 64-bit, I'm doing 64-bit, so on this one. Okay, should be all you need to do. So it should be able to find CL, yeah. Now, so this CL.lib, in case it's here, and I just want to add, it's being phased out, I don't care about it. And so there's a few things you need to do. You need to add the include directory. Windows 32-bit, I don't care for this. Look, only 64-bit. Yeah. Because who cares about 32-bit these days anyway? It's being phased out, I don't care about it. So go to the directory where the SDK installed, in my case it's here, and I just want to add this include directory. Okay, that, go to the link. Go to the link, and add this include directory. So it stays in there. Yeah. To add the include directory, Windows 32-bit. I don't care for this. Only 64-bit. Yeah. Yeah. Who cares about 32-bit these days anyway? It's being phased out, I don't care about it. So go to the directory where the SDK installed, in my case it's here, and I just want to add this into the directory. Okay, that, go to the link, and so it needs a dependency on the opencl.lib, and that is located in the same place. Oh, doesn't remember the last place, sorry. Was that? Run it again, lib, and that's 32-bit, 64-bit, Windows 64-bit, so I want this one. Okay.
OpenCL.lib I need to add. Tools, compiler options. Oh. Let's actually find it first. Okay, so it's gonna be in program file. Okay, there, boom. Lib. Or I guess we're just doing this one. I don't know. Look at that, OpenCL.lib. Wait, lib OpenCL.a. I think we want that one. That looks more familiar to the other ones I'm like. If you go into dev C++ libraries, like everything's a .a. Lib, like let's do like lib, lib GDI 32. Well, here's libbgi.a. That's like the first one we ever linked to. LBGI, so that's how you... Now it says lib, but we shortcut that to L. Same with lcurl. We just say lcurl when it's actually libcurl.a. So we just shortcut that to L, and then the name of the thing, and then we leave off .a. So in this case, we would say L OpenCL. We'd leave off .a. L OpenCL. I think that's right. Let me add that to my notes then. Okay, and it was GDI 32 as the last known. Okay, so we would add L OpenCL. Okay, and then we also want to make a note of what that is. Tools, compiler options. Ooh, they just deleted it. You have to click OK. Okay. Let me get rid of that. I think we're good.
Should be all you need to do. So hopefully it should be able to find. See, oh yeah. Now, so this header file is if you want to just use the standard OpenCL C API. In my case, I'll use the C++ API. So I'll do that, create a simple main function, and I'll just call something.
cl.hpp cl/cl.ht. Whoa. Yeesh. Huh. Oh no, can I find OpenCL? What? Hmm. Huh? Uh, should I just move it into the... This is pretty ghetto, but... I just copied it into here. Oh, that worked. Okay. That was weird. Glut32.lib. Here's glue32. GLEW. AMDOC. Don't see that. That was weird. We got it to work by drag and dropping. I wonder. Huh. That was strange. Ooh. I don't even know what's going on now. Like, shouldn't we just put these directly into the dev C++ stuff, maybe? That would be kind of nice, I think. This is kind of weird, though. But this could be smart. Oh, is that why? Wait! What if it's because we just stopped at lib instead of times 86? Whoa, 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 whoa. Let me delete that. Make sure it fails again. Okay, it fails again. What if we go Tools, Compiler Options, Directories, Libraries, and we correct that? Because I think that's what it's doing. Let's see it. Go to that. Here's the AMD app 3.0. Lib times 86. Okay. Add. And then we get rid of the one that didn't have that. Now we click OK. I think that will fix it, maybe. Oh, that fixed it! Whoa. That is crazy, guys. I'm solving stuff. Quick editor's note. So what happened there was, because they split up the lib folder into times 86 and times 64-bit or whatever, because they forked it into multiple folders before they actually had the lib, like the actual library files. I mean the library, yeah, the .lib files. Because of that, my IDE was only checking in the lib folder for the .lib files. It wasn't able to check any subfolders within within the overarching lib folder for the .lib files, which it should do. If you give it a folder name to check for lib files in called lib, it should check any subfolders within that folder for lib files as well. So it should first check the base lib folder for any .lib files. If it doesn't find it, or even if it finds them there, if there's other folders in that folder, it should open those up and check in there as well. But it doesn't do that, and so because of that, it wasn't finding the .lib file. So we had to instruct it to go into lib and then to go into times 86 to actually find the 32-bit .lib files. That's it, right? Wow, we got it. Okay. Um. We could maybe even create a dev pack of all this stuff. Maybe. And by the way, that there was some pretty juicy looking stuff as far as this might be smart actually to use these docks. Hi, Tattoo Lover. I didn't see your message. Trying to figure out how to use open, what's it called? OpenCL. Man. I can do that. I wonder... Hmm. Yeah, the include file I did here, opencl.h, I want to know what's in that. Oh wow, opencl.h includes all of these. Everything in here it includes pretty much. That's what it does. So we got it all. Whoa. CL underscore GL includes this. Okay. CL.H is the big boy though. So that's... Which one will be though? It's gonna be this one. That's fine. Okay. What? I'm
I gotta,
streaming.
I gotta go, and the Bobs are outside with your dad, and he says he's gonna only have him for about another 10 minutes.
What?
Can you look at the bot down?
I thought you said 10 minutes.
Yeah, but I just might as well do it now. Leave it up earlier today because I've been sick.
Yeah, but it's supposed to be a good schedule. 1:30 is when I do it.
Baby, please, when you were sick, can you just come down? I put the little dot down. I'm just gonna get that.
Okay. Alright, boys, I'm gonna end it here. I have to go put down the baby, and I nap when they nap. So, we. The initial idea 7 hours ago was super exciting, and it's still exciting, but I've almost lost sight of that because I've gone down this rabbit hole. So basically, the idea was we wanted to calculate taking in vertices for 3D models from a file, and then calculate like their rotation and their location in a 3D world, and their location offset with respect to our camera position, so to speak, in order to create in 3D space in our camera the different vertices of an object, and then using that information we would then run a pixel shader, and then we would use rasterization to create a 2D image out of it, and in some way I guess we'd be able to then basically calculate every pixel, and then we'd copy that to the window and thereby create our own 3D graphics. And I went through and I explained all these ways that would really help me to understand it deeper and help me to do computer vision and stuff and really understand how to tap into the power of a GPU. So I was doing that, and then it turned out like tapping into the power of a GPU is kind of hard. You have to use OpenCL, I guess. And so now I'm learning how to use OpenCL to use the GPU for these calculations. And I did not want to use OpenGL or DirectX or anything like that. I'm making my own graphics library, but in order to do that, you have to be able to interface with the graphics card yourself with your code, and OpenCL helps in that manner, because you can't do it without OpenCL or something like it. Unless if you want to create video card drivers, which you don't want to do at all. Like, that's ridiculous. So OpenCL is the lowest level thing you can do to speak to the existing video card drivers directly, communicate with them at high speeds, and tell the video card drivers this is what we want to do. The video card driver has OpenCL support. So OpenCL talks to it directly, we tell it to do things, it makes calculations for it and reports back to us. So OpenCL is the key to talking to the video card. And we're still not really cheating. We're not cheating at all as far as the graphics programming. We're still doing all the graphics programming ourselves, but OpenCL is the tool or the communications protocol to speak with the video card. Just like we have to use the SSL protocol and SFTP protocol to communicate with the server, but we implement that protocol ourselves rather than use a library that does it. The same way, we're not using the OpenGL library that does it all. We're using the OpenCL communications protocol to talk directly to the video card. And so we're not like using quote unquote library, even though OpenCL is technically a library. But we used OpenSSL for our SFTP client, so it's kind of like you have to use some libraries, but we want to use the least possible and the lowest level possible, so that we don't get into too high level abstraction, not know what's going on under the hood. We want to know as much as possible what's going on under the hood. And this is great. I mean, we're pretty much like tapping into kernel functionality that's running on the video card itself. This is really what I wanted. So this is great. We'll be able to use video cards going forward, big time. And I got it all working too. It's compiling and running with no errors. So I guess I figured out how to actually install OpenCL. I took notes on it and everything. Now actually going through and getting sample programs to work is going to be a task because it's like super involved. There's a lot of steps and it's complex stuff. So that's kind of my next job, and that's kind of annoying because I was already on something complex, which is like creating the graphics library. But now this is something complex, like tapping that library into this OpenCL thing. So it's like, oh, which one do I even focus on first? It's like two separate, huge, complex things that I'm trying to wrap my head around, and that kind of threw me off because I'm like, I'm trying to visualize how to create graphics in my head and do all the math, and it's like that's enough to focus on. And now it's like I have to do this immense project to get this interface to talk directly to the graphics card going, and that's a whole separate challenge with all these pages of stuff you have to figure out. So that made this whole project kind of slow down to almost a screeching halt as I try to get that aspect going. So it's very frustrating actually. But this is going to pay off huge, and I think this will help a lot of people. So this is still pretty cool though. So alright guys, that's where we were leaving off. I'm going to go take a nap. My daughters are taking a nap, and then I'll be back when I'm back, but I have to babysit the rest of the day. So I got a lot done on this agenda. It's pretty cool. So peace out guys. I'm excited about the progress. I'm tired though now.